In this example, we're going to use the normal curve to perform a one-sided hypothesis test at alpha is 0.05, but we're going to use a confidence interval to do it. So if we go ahead and draw ourselves a normal curve, which we always use to get started here, we're going to put x bar in the middle once again, and we're going to use same hypothesis statements that we used in the previous example, that mu is equal to 3.7, or mu is, we're not going to say equal to, we're going to say that mu is less than. So our goal is to prove that mu is less than 3.7. Now if we're doing our confidence interval here, and we said that x bar is equal to 2.5, we want to figure out how big of a confidence interval we want so that each tail is 0.05 or 5%. So looking at this curve, if we want the tail to be 5%, and I'll explain why I'm using the right tail even though it's less than, that's going to really make you frustrated for a moment, but go with it. Why we want this right tail to be 5%, then for our confidence interval we would have to end up with a middle region that cuts off 5% on each side for a standard symmetrical confidence interval that we're used to. If we have 5% on the left, 5% on the right, that's going to leave us 90% in the middle that we're going to find a confidence interval for. So to start over, we have our sample mean of 2.5. We got that from collecting our data. We create a 90% confidence interval. We don't need null or alternative hypotheses to do that. We'll get to that part next. So we create our interval, and let's say it goes from 1.8 to 3.2. So it's a little bit smaller interval than before because it's only at 90% confidence. If we are trying to prove that 3.7 falls outside of the confidence interval, we will have effectively proven that it is going to have a p-value of less than this tail here. So 3.7 somewhere out in the tail, which means that it has actually a very small p-value, most likely. It's hard to tell exactly how small, but what I do know is that if this tail is 5%, then the region bounded by 3.7 is something less than 5%. Now because it's less than 5%, and that's our general alpha, in this case it is our alpha, we would reject. So by falling outside of the confidence interval, we reject. Last thing I want to go back to is the part I told you we would look at is, why did I look in the right tail when it says less than? Well, that's because of the way I drew the curve. If you look at the middle here, I have x bar, and if you remember when we generally do hypothesis tests, we draw our mu in the middle. We put our null hypothesis of mu is equal to 3.7 in the middle, which means that our x bar, our sample average, would fall down here somewhere. So if we are starting with the confidence interval, we've effectively shifted over which tail we're looking at. We took this curve here and we said, okay, we are no longer looking at the left side of this curve, we are looking at the right side of this curve. So that's why I switched tails when I did this. The whole point of these problems, if you're wondering, okay, this seems like a lot of mental gymnastics for nothing, is to make the very explicit connection between confidence intervals and hypothesis tests. Confidence intervals say what is inside, what is included. Hypothesis tests say what is outside. How can I reject something? So it's all about the inside versus the outside. It's just the complement of each other when you're talking about probability, and we can use that to help us make decisions using confidence intervals.